So as I mentioned, today we're going to discuss the projections. Projections is one of the important topics in the engineering drawing. You could say that this is the start of this course, kind of, okay? Although we already covered a great part on how to practice how we can generate two-dimensional sketches in general. So other thing is just to acknowledge these projections and how you can represent objects, solid objects, in using the projections technique in the used for engineering drawing. So the objective, as we discussed in the start of this class, that you should have something, whatever in your mind or your head or in front of you, like you already have a solid object, and you are required to describe this object or represent this object using graphical things, which is the engineering drawing. If this object is related to some engineering application, so your graphics, it should be related to the concepts of the engineering drawing. Like assume that you do have this 3D solid, and you are required to describe this solid to somebody else graphically using the graphic. So we said that we can use the verbal description, just you're gonna directly verbally start to describe this object, but this verbal description is not effective because this object is very simple, right? But for complicated objects, it's gonna be very hard, very tough to you to verbally describe something. The best way is just to take a picture of this object or to graphically represent it. So as we discussed through this class, that the objective is just to know how we can describe objects based on engineering drawing, using the engineering drawing. So one of the ways of representing the object, what we practiced so far, by the way, in this course, we just practice how we can create two-dimensional sketches based on the concepts of engineering drawing. Now we're gonna use this skill that we already practiced on to create or to generate projections of a certain object. Like assume that you do have this object and you are required to represent this object into some projections. So I'm gonna explain what does it mean projection. But for example, if you already have this like one view of the object, okay, you can understand what is this thing. Why? Because it is already represented as three-dimensional view, right? So view in engineering drawing, it is a representation of a whole body or a portion of it. It is representation of something within this body, how you're gonna look or how you're gonna see this object from a certain angle. This is view. Like you already putting an angle and you already using your cell phone and you taking a picture of it. Okay, so you're gonna take one picture from one certain angle. This is gonna be view. So view in engineering drawing is just a representation of whatever the whole body or a portion of it from a certain angle. This is an engineering view. The view, it would be three-dimensional view like this case, or it would be two-dimensional view like this case. So this is three-dimensional representation, but this is two-dimensional representation of the same object, by the way. They do have the same object, right? But as you can see here, we are working in just XY coordinates, but here we're already working over the three coordinates X, Y, and Z. So this is three-dimensional view. This is two-dimensional view. Make sense? Yes, so this is one of the most common types of three-dimensional representation of object is the isometric view, okay? We do have different types of three-dimensional views. One of the most common one is the isometric, and this is the one that we're gonna use, which stands for isometric system. Like this, you can break down the word into ISO, which is the international system. This is the ISO system that we agreed that we're gonna use for the engineering drawing. Metric, because most here already our basic unit system that used in the UE or most of the European countries is the metric system. So this is the isometric system view, which representing the three-dimensional representation of an object, okay? But in addition to the isometric, there are some other three-dimensional representation or three-dimensional views like the oblique. The oblique is used in some countries like the United States, like Japan, for example. They already using the oblique system or three-dimensional representation of object using the oblique projection or oblique three-dimensional view. But as I mentioned, most of the other countries, like the Middle East countries, we already using the isometric projection or the isometric three-dimensional view. Okay, what is the difference between these two? In the oblique system, we would focus on the face or the front of an object. Like for example, if I ask you to describe somebody, so you're just gonna, the first thing that you're gonna start to describe him is his face, right? So this face would be considered like this is the front of the object, front of this guy, this is the face of this guy. So in the oblique system, we would focus on the face. Like for example, if you have an object, we already representing this object, the face of this object with the exact dimensions. Like for example, in some cases, we may represent the three-dimension axes like x, let's say, like for example, x, z, and y coordinate, for example, or let us assume that this is y and z. So you're gonna have the x-axis and the y-axis, they like square, right? This is one way, this is one of the methods that we basically represent the x, y, and z coordinate. Or we may represent them in this way. So this is gonna be like the x-axis, and this is gonna be like the z-axis or the y-axis even, and we're gonna have the z-axis. So as you can see, the x and z-axis, they already inclined with certain angle to the horizontal axis, right? So this is one of the, we sometimes represent the xy axis, the Cartesian coordinates, we represent them in this way. In some other cases, we would represent them in this way. So this is like oblique projection. This is the oblique thing, but this is the isometric projection. So in the oblique, we would focus over the face. Like all the dimensions of this face are exact dimensions. But in the isometric, we would focus over these three edges. So the dimensions here, it means that this face and this face, they won't gonna be seen with their exact dimensions, with approximate dimensions. But again, the main difference between the isometric and the oblique, in the oblique we would focus over this face, but in the isometric we would focus over these edges, okay? This is very common in the Middle East, as I said, and that's why through this course, we're gonna focus more on the isometric three-dimensional view. This is what we're gonna use through this class. But remember that still we are talking about three-dimensional view, okay? In the isometric, we have to give inclination to this edge and this edge of this box with 30 degrees and 30 degrees. This 30 degrees is a fixed, this is a standard thing. If you decided to use different angle, this is not an isometric, okay? So in isometric view, we should stick to the 30 degrees, do inclination to these edges over the horizontal axis with the 30 degrees. But in the oblique, we draw the face with the exact dimensions, then we give extension. Like you draw a face and you give it extension in this direction with an angle 45 degrees. Okay, and again, this 45 degrees is a standard thing in the oblique view. Okay, and again, the thing that we're gonna focus on is the three-dimensional view using the isometric. All right, so this is in the beginning. What does it mean, three-dimensional view? What does it mean, isometric or oblique view? And the focus again is gonna be over the isometric. In today's lecture, I will not discuss or show you how we can create or generate isometric view. It means that we will not practice these things today. But the thing that we're gonna practice on is how we can project. It comes like projector, like you have a projector or you're already taking a picture of the object from different angles. So you're gonna end up with different pose or different faces of the object. These are the projections. So projection, it's simply how you can convert a three-dimensional object. Like assume that you do have object, real object, like you're already handling this object, and you are required to describe this object from different views. So this is like you already doing projection of a three-dimensional object into two-dimensional views. Okay? So what is the difference between three-dimensional view, like isometric, and two-dimensional view. This is three-dimensional. It is very clear because you have like, you can see three edges of the object, like the thickness, the height, in addition to the length. So we do have like X, Y, and Z axes. But here we can see only two edges of this object, like the X edge and the Y edge, or X axis and Y axis. So this is two-dimensional view. So what is the difference? The three-dimensional view, it gives a description of a solid body. Also, two-dimensional view gives a description of the same solid body. No problem. Like these are represent some description or provide some information about this solid object. Okay, the three-dimension, it completely describes the object, and only one view is enough to completely understand the details of this object using three-dimensional view. So for example, if you have a look to this shape and I ask you what it is, you're gonna say that this is like a small box with a big opening in the middle, in the center, right? So you understand what is this object exactly. But if you're gonna look to the two-dimensional view, it won't gonna give us a complete understanding of the object. It means that one two-dimensional view is not enough to fully describe the details of the solid body. So that's why the two-dimensional projections or the two-dimensional views, we have to represent more than one, so we could understand what this object is. Make sense? This is the big difference between the three-dimensional representation or the three-dimensional view like isometric and the projected view, which is the two-dimensional view. So the two-dimensional is commonly known as the projected view, and this is the focus on. The focus today is to show you how we can extract the projected views, the two-dimensional views, from a three-dimensional object. You got my point? Like for example, like this case, if I ask you to describe the face of this object, this surface, so you're gonna say that this surface only, this face only, is just like square, right? With four edges in this way, and there is a big circle in the middle. So if to draw this thing, it should be represented as square with big circle in the middle, right? So this thing is just one face. This projected view, it is just one face of this three-dimensional object. But if I ask you to describe this edge, how it looks like, it is rectangular shape and it is standing, right? So it's gonna be represented in this way. So this is another view. This face is another view, is another projected view. If I ask you to describe this edge, so it will be also rectangular, but it should be aligned horizontal, kind of. Okay, so this is another projection. So all of these are different projections of the original three-dimensional object. Three-dimensional object is one view is enough to understand what is the shape, but the projections, you need more than one projection. You need more than one projected view to understand the solid object. Make sense? So again, the objective today is how we can extract these projections from a given three-dimensional solid. The next week, we're gonna have the midterm. The week after, we're gonna discuss, we're gonna do the object, how opposite. How about if you already given the projections, how you can extract the three-dimensional object, how you can build them together to end up with a three-dimensional object. Make sense? So projection, generally any object has infinite number of projections. So if we have object like this one, how many projections, how many faces that this object would have? This object has 6 faces, right? Like this is face 1 and there is a back, and this is face 2, face 3, face 5, 6. So in general we do have 6 faces, like 6 angles, main angles of the object, so we can see it, okay? But generally, any object, the projection is just like taking a picture of this object from a certain angle. So you can take this picture from any angle, whatever it is. So the projections in general in total, the count or the number of the projected view for any object, it should be infinity, because I could look at it from any angle, whatever it is. You can take a picture from any angle, right? So that's why the number of the projections for any object, it is huge number. As I mentioned, if you already have any object, you can take a picture from this for the same for the object from different angles, from so many huge number of angles. At any angle, this is a different view. This is a different projected view. Make sense? But in terms of engineering, there are 6 common projected view. Like if we do have this cubic shape, it has 6 faces, so that's why it is common in engineering to have 6 faces of projections, okay, or 6 projected views. So by the way, this 3 dimension, is it isometric or oblique? Anyone? Yes, oblique. Why? Because I'm focusing over this face, right? This face is represented because in the cube, this face, it should be square. So I presented this one as a square and I extended over a 45 degree, right? So this is like oblique. But if I decided to draw this cube as isometric, it should be represented in such a way that these 2 edges should be inclined with 30 degrees, and this is the vertical edge. Then you're gonna have this face, and this is the second face. Then you're gonna complete the shape. Make sense? So this is gonna be isometric. The one here, it should be blue, it should be the isometric. Anyway, so how many faces do we have for this box or this cube? We do have 6 faces, right? We do have 1 front face and we do have another 1 in the back. So that's why we do have the front view or the back view. Front of an object and the back of an object. Like if I ask you to describe somebody, this guy has a face. His face, this is the front, and he has back. So his back, this is another view. Okay. The front view, it is commonly known as the elevation. This is the elevation view or the front view of the object. But in addition to the front view and the back, assuming that you're already standing here, looking to the front, and you try to touch these sides by your hand, there should be side face here and there should be another side, right? Assume that you're already standing, looking to the front view of this object. So this face, this side, if I ask you to touch it or just pick it with your hand, which hand that you're gonna use? The right one or the left one? What again? You're already standing in front of the object, facing the front view, looking to the front view. Asking you to touch this side by your hand. Which hand that you're gonna use? The right hand or the left hand? We do have for any object, whatever it is, we do have an engineering drawing 6 projections. These projections are front view, back view, right side view, left side, top view, and bottom view. Like if you do have this box, this cube, it has front, it has back. If you're gonna look at it from the back, it has right side. This is the right side of the object, and this is the left side of the object, and there is the top, and this is the bottom surface of the object. Okay. And generally speaking, we have 2 approaches, 2 standard things in representing the projections. We do have the first angle projection, and we do have the third angle projection. The one that we're gonna use through this course is the first angle projection. Why? Because this is acceptable by the isometric or the ISO international, that matches the isometric representation and this is acceptable internationally in most all the countries except the United States. United States, they already using, and Japan, they already using the third angle projection. In the first angle projection, it is like you're already holding a torch or like a flashlight, and you already posting this one to the object. So the shadow of the object will be seen in the back. If you already standing here and looking to the object and assume that there is light, so that you're gonna see the shadow. The same thing if you already standing here looking from the top, you're gonna see the shadow of the shape. So this is the basic idea of the first angle projection. But in the third angle projection, looks like you're already taking a picture. So if you're taking a picture, you're already standing here, and you're gonna receive the picture on your cell phone in the same side that you're already standing in. But here you're already looking to the object, and the representation, it should be in the back. Like this is the shadow of the object. But here this is like you're already taking a picture, and the picture, you're gonna receive the picture in your side over your cell phone. Also, like you're already standing here and you're already taking a picture, and you're gonna see the picture in your cell phone in your side. The same thing if you're gonna look at it from the top. Okay, this is the big difference between the third angle projection and the first angle projection. The main difference will be clear when we are representing or arranging these multiple views. We said that in general we do have 6 views of any object: the front, the back, the right, the left, the top, and the bottom view. So how we can allocate, how we can arrange the 6 views together, this what distinguish the first angle projection from the third angle projection. For example, in the first angle projection, we put the front in the middle. This is the front view, and we put here one of the 2 sides, and we put the bottom on the top, and the top view should be represented down here. This is top view, this is the bottom view. And on the right of the left, we're gonna represent the left hand side view, and on the left of the front, we're gonna represent the right hand side view, as we agreed that we do have 2 sides, one right side, one left side. The right side, this is the one, if you're already standing here in the front and you try to touch this side by your hand, you have to use your right hand. But if you're already standing in the front and you try to touch the other side, you have to use your left hand. So that's why this one is a right hand and this one is a left hand. So this is right hand side, this is the left hand side. This is the RHS and this is the LHF. S. So in the first angle projection, we are putting the left hand side on the right of the front view, and the right hand side, it should be represented over the left, on the left of the front view. The bottom view, we do have for this object bottom and top view. The top view should be below the front view, and on the top, above the front view, there should be the bottom view. This is the first angle projection. So as you can see, everything is reversed, kind of. The left is gonna be on the right is gonna be on the left, the top is gonna be blue on the bottom, and the bottom is gonna be on the top. Okay? And the third angle projection, it presents, we start with the front. So as you can see, all the time we start with the front and then we arrange the other views around the front view, right? So we start from the front, and the right is gonna be on the right side. And the left side, it should be represented on the left side. And the top, it should be represented on the top of the front view. And the bottom, it should be represented on the bottom of the front view. So in the third angle projection, which is acceptable by the USA and some other countries, this is like the American system of engineering drawing. Like we do have 2 systems for the unit system, metric system or international system, and we do have the American system, the inch system. This is like the inch system for the units. This is the third angle projection of engineering drawing, that we represent the front, and the top view, it should be shown on the top of the front. The side view, the right hand side, it should be represented on the right of the front. The left side, it should be represented on the left of the front. The bottom, it should be on the bottom of the front. But here we're already reversing everything. This is the first angle projection. This is the third angle projection. This is the thing that we're gonna use in this course, the third angle projection. So when we are required or being asked to represent the object over projections, we're gonna use the front view. One of the sides is enough, and top view. We said that in general we'd have 6 views. It is not necessary all the time to represent the object using all the 6 of them. 3 of them are enough. In some cases, 2 of them are enough. In some other cases, 1 view is enough. This depends on the details of the object, the feature of the object. If the object is simple, you can represent it in just 1 view or 2 views. But if it is complicated, it is recommended to represent this object over multiple views, like 3 views. Even we can add more than 3. It depends on the complications, on the feature, how complicated is the solid object. So that's why in this course now we're gonna focus on 3 views only, 3 views. One essential view, it should be definitely the front view. For example, if I ask you to describe somebody, the first thing that you're gonna describe him is his face. He has big nose, he has whatever, so you're gonna just start to describe him with his feature. Try to describe him as much as you can, right? So this is the front view, this is the face of the object. This is the first view that you have to draw. Then, on the right or the left of the front view, you're gonna represent one of the sides. One of the sides is enough. But if you decided to represent the left-hand side, it should be drawn on the right of the front view. If you decided to represent the right-hand side, it should be represented on the left of the front view. And the top view definitely should be blue or down the front view. Make sense? So this is how we are going to arrange. We're gonna use the front, one of the sides, and the top view to represent the projections of a 3D solid. Make sense? But there are some essential points that should be considered. For example, if I give you a solid object like this one, this is a 3-dimensional object, and these are 3 projections. So if I ask you what is this projection is, this one, it should be the front view, and this one, it should be the top view, and this should be the side view. But which side? It should be the left-hand side view. Why? Because we're already working first angle projection. Like if you're already standing here, assume that you're already standing here, looking to this shape. So these features, these are the things that you're gonna see, all of this face. This is what you're gonna see, right? Which is this one. So this is the front view. If I ask you, now if you're already looking from this side, and you're already standing here, and I ask you to try to touch this side, you're gonna touch this side by your left hand. So this is gonna be left-hand side. It should be represented on the right of the front view according to the first angle projection system that we're already using. Also, when you're gonna look to the top view, you have to try to move on the top and look to the shape from the top view. So you're gonna see this shape. This is how it's gonna look like from the top view. It would be, you know, like crazy thing to you to have all of these lines and all of these details, but as we practice, it's gonna be clear to you. But anyway, there is an essential point that you should understand here, that it is not possible. For example, how about if you're already working and drawing, for example, the front view, or for some reason there is no space in the drawing sheet to draw the side view. So is it fine to draw this one over a separate sheet? No. These 3 views should be arranged in a certain way, in such a way that the maximum height of the front view, it should exactly equal to the maximum height of the side view. And the maximum width of the front view, it should be typically the same like the top view. Also, the spacing between the front and the side view, it is recommended to be the same. And any feature that is represented in the front, like this hole, this circle, it should have projections over the side and projections over the front view. So what does it mean? It means that any feature in the front, it should be represented in the other views. Any feature in the side, it should be seen in the other two views, and so on. So it means that anything in the object, whole, circle, whatever it is, it should be projected over the three views, as we're gonna practice and see. Make sense? So this is the basic idea of the projection. And again, the objective is that you will be given three-dimensional view like this one. This is isometric. You will be given isometric like this one, and your objective is just to project this isometric, represent this isometric into three views. Essentially, you should have front view and one of the sides in addition to the top view. Okay? If you already given another thing, if you already given this 3D solid, and I ask you what is the face of this solid is. The face or the front view, it should be the biggest one, the wider area, and include most of the details of the object. It should be appearing in the front view. So this is an essential sense. For example, you already given this 3D solid. So which side, which angle that it should be considered as the front view? You can look at it as from this angle. We're gonna look at it from this angle and from the top, right? So definitely this makes sense that to have this one at the top view, this angle. But can I consider this angle the front view or this angle is the front view? Pick the angle that gives most of the details of the object with the bigger size, with the bigger wider area. As you can see, all the details are very clearly seen in the front view. So make this view at the front view. But this one is not recommended like this one as front view. This one is side view, that's fine. This one is top view, that is fine. But this one, it should be the front view. So make all the time, try to pick the angle that gives most of the details of the object to be the front view. Like for example, if I ask you to describe your friend or your classmate, the first thing that you're gonna describe him is his face. This is the essential thing, right? Why? Because most of the features and detail, or what distinguish your classmate from another classmate, is his face, right? So basically speaking, it's the same thing for the solid objects. What distinguishes this object from another thing mainly is gonna be his face, or its front view. So make the front view is the view that include most of the details of the object, in addition the bigger and the wider one. Make sense? Okay, so just to explain these things with more details to you, let us consider these projections, these 6 simple examples. Assume that this is the 3D solid. This is already the 3D solid. This is the 3D isometric, and these are the 3 projections. So in the beginning, if you are required to project this one into 3 views, definitely there should be a front view. So which side it should be preferred as a front view? Which side should be the side like A and B, right? Like this, it is preferred to be the front view. Why? Most of the details of this object is gonna be seen, clearly seen with their exact dimension in the front view, okay? From this view. In addition, it is the wider, this edge, it is wider than this one. If you already said, because these are the 3 views, you're gonna look at it from the front and from the side and from the top. So it is recommended to have this one at the front view, especially that you don't have this inclined edge. So this inclined edge, when you're gonna look at it from the front view, you're gonna see this one with a line, with the exact length of the edge, and that's why this is much more recommended to be the front view. So assume that you're already standing here, and I ask you to look to the shape. What faces that you would see from this view, from this angle? You're gonna see this edge, right? This surface A, agree? So we're gonna see this surface and we're gonna see surface B as well, right? But the question is, can you see surface G or surface C and the other surfaces? If you're standing here and looking to the shape, okay? So it means that you assume that you're already holding this object in front of you, directly in front of your eye, in such a way that you aren't gonna see except surface A and surface B, and that's it. Make sense? Then your objective is just to project this, represent these faces into a projection. So for example, if we give numbers, assume that this edge is 100, this edge is 90, and this thickness is 10, and this thickness is 10. This edge is 10, and this one is 10. So your objective is just to draw this angle, like two-dimensional drawing. So you're gonna start from this corner, for example. If we start from this point, if you're already standing here, it should be on my left, right? It should be on the left. So starting from this point, then you're gonna go to the right. You're already standing here. You're gonna go to this direction. Draw a horizontal line. This line, it is seen in the 3D as inclined line. But since you're already standing directly in front of this line or this edge, you're gonna see it horizontal one. Make sense? So that's why it will be represented as horizontal line. Then you're gonna go up, right, with 90. So then I'm gonna go up with 90. Then I'm gonna go to the left with 10, move to the left with 10. Then I'm gonna drop down with a vertical. What should be this vertical height? If you subtract 10 out of the 90, this is gonna give us 80, right? So this edge should be 80. So I'm gonna move down with 80. Then you're gonna move to the left with the 90. So I'm gonna move to the left with the 90. Then I'm gonna drop down with the 10 to close the shape. So this is gonna give us the first surface. How about the second surface, the second face, which is B? If I ask you to draw this B should be seen like this way, right? But it requires a start point. You need a point that you have to start from. So for example, how many corners do I have for this point B, for this surface B? Would you have point 1, point 2, point 3, point 4? Your objective is just to pick one of these points in the front of you. We're already working here. So which one of these 4 points that we already got there? Anyone? Point 1, this should be point 1, agree? And this should be point 4. And this should be point 3. Why? Because point 4, it should be over the same line at this point. But since you're already holding this one and you directly look at it from the A and B surfaces, so you're gonna see these 2 points like one single point, which is this one from this view. Make sense? So this should be like point 4. So we already got point 1 and 4 and 3. We're just seeking one point, only one point. Assuming that this distance, assuming that this edge, it is 20. So from point 1, for example, you're gonna draw from point 1, we're gonna draw a line with a length 20. Then if you connect this point to this point, you're gonna end up with the second face, which is surface B. Make sense? So this is how we can project this object into front of you. This is just the front of you. How about the other views? We still have the side, one side, and one top view. Let us move to the side view. What is the type of this side view? Is it right side or left side? You're already standing here, right? If I ask you to touch this side by your hand, which hand that you're gonna use? If you're already standing and looking, facing to the object, which hand that you're gonna use? The left one, okay? The left side view, it should be drawn on the right of the front view. Since we're already working using, based on the concept of the face angle projection. Make sense? Agree? So this left side, it should be drawn on the right of the front view, not on the left. Although it is left side, it should be represented on the right of the front view according to the first angle projection system that we're already using or following. Make sense? So to create this side view, there are some essential things that you should understand, as we discussed before, that the maximum height or any feature, whatever it is, in the front view, it should be seen in the side view. So for example, if I ask you, so what does it mean? It means that if you try to look to the front of you, we already draw this thing, and assume that this drawing and this drawing is not there yet. Okay? Assume that. So if you're gonna look to this front view from this angle, this way, you have to see the side view. So if I ask you to look to the side view from this front view in this way, what are the lines or the edges that you're gonna see? First of all, you're gonna see this edge, right? The green one. You're gonna see all of these edges. Agree? In addition, you're gonna see this edge. Agree? Okay? This one on the back, it won't gonna be, it would be not clear how you're gonna see this edge or this face from this angle to some of you, but no problem, that's fine. So your objective, what I mean here, your objective is just, remember that I didn't even go to this object, right? I just finished the front view, now I'm moving to or preparing. This is like you already preparing to draw the side view. So to prepare, try to imagine that you're gonna look at it from this angle. Why this angle, not the other one? Because this is left side and it should be represented on the right of the front view. Make sense? So what you're gonna do, your objective is just to connect, pick a point. Like if you try to look at it, so we do have one point, another point of these lines. Like we do have vertical line here. This vertical line should be projected there in the front, in the side view. So what you're gonna do, you're gonna draw a very light line. Assume that this line is a very light line. Extend this line. And this extension line, it should be barely seen. And then you're gonna extend this point into another line. Then do the same, this point it will be projected into another line. So do you see this maximum height? This should be the maximum height of the side view that you are going to generate. Make sense? Now you're gonna go to this side view. Now remember that we're still standing in the front of you. Now try to move yourself to be standing in front of the side view, looking to the side view. Assume that you're already standing here. What faces that you're gonna see? You're gonna see D and E and C, right? But B and G will not be seen, assuming again that you're already just holding this one directly in front of your face. So these are the faces that you're gonna see, right? Then your objective is just to represent these faces. Which face, if I ask you to arrange these faces, face D, it will be seen horizontal or vertical? Horizontal, so it will be horizontal in this way. This is face D, and E will be vertical, right? And then you're gonna find C next to it on the right. Like E is gonna be on your left, and C is gonna be directly in front of you. Make sense? So this is how it looks like. So your objective is just to represent the things here. So let us assume some dimensions. Assume that this edge, it is 60, and this edge is just 10. So to draw the D surface, it should be seen like rectangular face. And again, we have to pick start point. Let us choose this point on the left, because we're already standing here, so this should be on the left. So what you're gonna do, we just connected some lines. We draw some horizontal lines from all these points. We draw horizontal lines. Then your objective is just to choose any distance. You have to keep distance between the front and the side view. This distance, how much it is, it's up to you. It depends on the drawing sheet that you have. But let us assume that you can keep from 10 millimeters to 20 millimeters distance between the front and the side view in most of the exercises that we are going to consider. Make sense? So if you're already standing in the side view and this is gonna be the point, this point, we're gonna start from this point. Definitely this point, it should be Just pick any point, just measure from this down, because this is the lower left corner of the view, which it should be this one, right? So from this point, draw any vertical line. This is gonna be the start. You could consider that this, all of this area, this side view should be seen within this area. Starting from this line to the right. And it shouldn't exceed this line or this line. It should be confined between these two lines. You got it? Okay? So this line, this vertical line, and these two horizontal lines, these are my limits for the side view. Then starting from this point, which it should be the lower left corner, I'm gonna draw a line. If you're already standing here, moving to the right, so I'm gonna move to the right with 60. Then I'm gonna jump up with this height. This height is already 10. And then you're gonna move to the left. And then you're gonna drop down. As you can see, this D, it should be confined within these two lines. This is the height of surface D, which should be typically the same, because this edge, it is one of the edges of this surface D. So the drawing is consistent. How about surface E? Surface E, it has width, but it needs start point. We do have multiple points. We may have this corner, this corner, this corner, this corner. Which one of these four corners that we already have? This one. So starting from this corner, which is this one, this point, I'm gonna move to the right with 10. Then from this point, I'm gonna jump up. How long? What is the height of this surface E? How much? Yeah, it should be 81, because this line, it is inclined line. This one is inclined line. So if you try to project it into this direction, you're gonna set up like 90 triangular shape, right? So the projection of this thing, of this line, it will be seen from this side as with this height, but it will be seen from the top view with this length. But from the front view, it will be with the exact length. So this is the exact length of the inclined surface, but this is projected length or projected height, and here it will be seen with a projected length. Okay? So this height, it should be 80, and this area it will be obtained automatically. There is no need even to calculate it, because why? Because this is the inclined surface. So if I ask you to project it, it should be projected this way. If you have this point and move to the right, this is going to give us the first edge. Move to the right, you're going to end up with the second edge. So this is going to give us the surface E. Make sense? How about surface C? Surface C automatically is going to be there just to close the shape. This is going to give us the surface C. So that's why it is highly recommended to have this yellow lines to be drawn first. This horizontal line, draw them first, very light, because they shouldn't be there in the drawing. It's going to assist you to come up with the other view. And let us do the same for the top view. For the top view, if I ask you to look at it, if we try to look at it from the top, so these are the faces that we're gonna see, right? All of these things will be seen, including even this inclined surface, right? Including this one as well. So as you can see, if you try to look to the shape from the top view, you're gonna see this horizontal line, and you're gonna see also this inclined line, and you're gonna see this horizontal line, but you aren't gonna see any vertical line. So basically speaking, or generally speaking, we have three lines that should be projected down. If we choose this horizontal line, this first horizontal line, from the start point, move down vertical. And from its end, move down vertical, very light line that is barely seen. And the inclined surface, do the same. From the start point, move down. From the end point, move down. And for this horizontal line, from the start point, move down. From the end point, move down. So we end up with four lines already projected from the top view. This is the maximum width of the top view that is allowed to us. It should be the same width as the front view. Make sense? Then you're gonna keep distance. Typically the same distance that you kept between the front and the side view, you have to keep the same distance here between the front and the top view. If you just choose 20 millimeter, so you're gonna keep distance here 20 millimeter as well. Then you're gonna measure the 20, then you're gonna draw a horizontal line. This horizontal line is going to intersect with these 4 vertical lines in 4 points or 4 corners, like 2 corners. We do have this corner on the right and we do have this corner on the left. So now we're just preparing to the top view. Now we're gonna go to the 3-dimensional object to extract the top view, to come up with the top view of the shape. Make sense? So remember, where we are standing now, we're still standing here. We just finished the side view, right? We didn't move anywhere. We're still standing in the side view, right? Since we're still standing in the side view, when you try to imagine or come up with the top view, you have to move back to the front view. You have to move back again to the front view. Don't try to imagine the top view while you're already standing in the side view or from the side view. It is wrong. The top view, since it will be represented below the front view, you have to move back again to the front view. Then you're gonna imagine the top view. Make sense? If I ask you what are the faces or the surfaces that you're gonna see from the top view, which faces that we're gonna see from the top view? We're gonna see F, the inclined surface, right? We're gonna see the F, which is this like angle surface, in addition to G. Agree? We do have 2 possibilities for representing these 3 projections or these 3 surfaces. We may have, like, we would represent them as already represented in the drawing here. This is F and this is E surface, and then we're gonna have G. This is F, E, and G. Which one is correct, this one or the one in the drawing? Definitely you're gonna tell me that this is the correct one. Why? But if you move back to the front view again and try to look at it, so how it works, assume that you're already holding this object in your hand, but while you're already standing in the front view, and try to rotate the object and direct the object directly to your face. Try to give it rotation to be directly, assume that you're already holding it, handling it, and give it rotation to be directly facing your face. So you're gonna see the F surface will be seen vertical on the right, it will be seen this way, then the E surface will be seen on the top, and then the G surface will be something in front of you, as already represented here. Make sense? Then using these edges, so for example, this edge, this point, this is the highest, this is the top left corner, which it should be this point. Or this point is gonna be the top right corner of the top view, which it should be this point. So starting from either this point or this point, you're gonna go ahead and generate the drawing. This edge, how long it is? It is 60. So you're gonna drop down with 60. Then this edge is 10. So you're gonna move to the left with 10. Then this edge is, if you subtract 10 out of 60, this is gonna give us 50. Then you're gonna move 20, or you're gonna move 20 plus the other. So all the way, you're just gonna move all the way till the end. Then there is an edge here to close, so you can see this is gonna be the surface F. And this is gonna be the surface E. Then you're gonna close the shape to end up with surface G. Make sense? So this is simply how we can extract and generate and draw the projections. And there is an essential thing, that these projections, they should be consistent together in terms of the heights, in terms of the width of the front view and the top view, the height of the side view. Any feature in the front view, it should be seen in the side and the top view as well. Make sense? So what we're gonna do, we're just gonna consider this exercise. For this example here, this is a 3D view, this is isometric view. As you can see, why this is isometric view, as you can see the edge, this edge and this edge, both are inclined over the horizontal surface lines with 30 degrees, right? So that's why this is a horizontal, I'm sorry, this is an isometric, right? And it is required to project this one into 3 views. So which one? Basically, we do have 3 directions that we can look to this shape from. 3 angles. This angle, this angle, this angle. Which one do you recommend? Angle 1 or angle 2 or angle 3 to be the front view? Which one that it should be the front view in your point of view? 1. Why? Because most of the features already seen from the one view, from this angle. So I'm gonna choose this one at the front view, and this definitely is gonna be the side view, and this definitely is gonna be the top view, right? And what is the type of this side view? Is it left or right? It's gonna be left side view. Why left side view? Because if you're already standing in the front, this is the side view that you're gonna see. Make sense? Then, if I ask you now, this is, assume that this is the drawing sheet. Assume that this is the drawing area. Okay? So, first of all, if you're already standing in the front view, what faces that you're gonna see? Okay? So, you're gonna see this face, and you're gonna see this face. In addition to this inclined surface will be seen, in addition to this face. Agree? Okay? So all of these faces will be seen, right? This one. So if I ask you to draw this shape and assume that we're gonna draw the front view, first of all, the front view, it should be, assume that this is the drawing area, this is the drawing sheet. Is it fine if I draw the front view here? Why? Because there is no space for the side view. Why? The side view, it is left side that it should be seen on the right of the front view. So if you draw the front view at the right corner, there is no space to the side view. So it means that the front view should be drawn on the left to keep distance or the space for the left side view, and then you're gonna have the top view. So this should be the front, the side, the left side, and the top view, right? So that's why I have to draw the side, the front view somehow on the next to the left corner or edge of the drawing sheet. Make sense? Then if you're already standing here and we would like to draw this shape, you can tentatively come up with the shape. So for example, this front view will be directly like this square is gonna be like one square on the left, and there is one square on the right, and this rectangular square in the middle is gonna be directly the inclined surface. Agree? Then on the top of this, you're gonna see this shape. See this shape of the front view. Okay, so let us draw this shape. It should be like 3 rectangular squares on the bottom here, right? Starting from this corner, for example, which should be this corner, because you're already standing in the front view. I'm gonna draw a horizontal line 40, then I'm gonna jump up with 10, then 40, and close the shape. And this gap in the middle, it should be 10. So what I'm gonna do, I'm gonna draw a horizontal line from the left, move to the right with 40. Then I'm gonna jump up with 10, then to the left 40, then down 10. Then I'm gonna break the shape in such a way that this distance in the middle, it should be 10. Make sense? Then I would like to draw this shape, this face, right? So I need a corner, a start point. Let us pick this corner, for example. This corner, it should be conceded to this corner, which it should be this point. Agree? Then from this point, I'm gonna jump up with this vertical height, which it should be the 10. This total height is 50. So this height is gonna be just 40 because this is 50. You're gonna subtract 10. So the remaining distance should be 40. So you're gonna jump up with 40. Then we're gonna go to the left with 10. Right? Then, or even you can draw a light line in the beginning, this way, and from the middle of this line, if this is 10 and this is from the other side 10, because if you just jump up from here with 40, you're gonna end up with this point. Then you're gonna draw 10 to the right, 10 to the left. You're gonna end up with these 2 points, which shall be these 2 points. Then this height is 10, and you should have like a triangle, like V shape in the middle, right? So this vertex, it should be located at a vertical distance from the middle, from the center of the shape at 10 millimeter. So if you draw a light line from the middle, and over this line, you're gonna measure 10 millimeter. You're gonna end up with this vertex. Then you're gonna connect them. You're gonna end up with the V shape. Yeah, that's 1 centimeter. 10 millimeter is already one centimeter on the scale that you already using. Okay. And also for this one, it is 20 millimeter. This gap, it is 20 millimeter, and this height, it is 25 millimeter. So from the center, from this center point, you're gonna measure 10 to the right, 10 to the left. Then you're gonna go up with 25. Then you're gonna close the shape. Make sense? Right, so this is for the front view. For the side view, what you're gonna do, you're just gonna try to look to the shape. Just prepare for the side view. So if I ask you to look to the shape from the side view, any vertical line or inclined line that you can see when you try to look at it from this direction, draw projections for this line. Like for example, how many vertical lines do we have? We do have this line, it is a vertical line, right? This line is a vertical line. This line is a vertical line. This line is a vertical line, yes, but it is identical to this one. So one is enough. The first one, this is the one that it's supposed to be seen, kind of, because this one is identical to this one. So one of them is enough. The same thing, this line is identical to this line. So one is enough. Then also this inclined surface, if you try, we're gonna see this inclined surface. And this one is identical, but if you see this one, you won't gonna see the other one. Make sense? So in total, we do have like 3 lines for now. Okay, like this vertical line, and remember there should be another edge here over it. And there is another vertical line, and inclined line. Your objective is just to project these lines on the side view. Project how? From the start and the end point, draw a very light line that is barely seen. From the end point, draw a very light line that is barely seen. How about this vertical line? From the start point, draw a line. From the end point, draw another line. This line, from the start, draw a line. From the end, draw another line. This inclined surface, from the start and the end, from the start, draw a line. From the end, draw another line. So you have to use all of these lines in the side view. Then what you're gonna do, you're just gonna measure a distance between the front and the side view. Let us assume distance, for example, of 20 millimeter or 10 millimeter, it's up to you. And then draw, just measure a distance between the front and the side view and draw a vertical line, very light line that is barely seen. Now we got the first point. We got one point, which is this corner. If this is the left-hand side view, we do have one point here, which is this one. This point, it should be located on the lower left corner of the side view, because the side view should be seen here, right? Now, move to the 3D solid. We're still standing in the front. Now let us move to the side view. When we move to the side view, what faces that we shall see from the side view? We're gonna see this L shape, right? This L face will be seen, right? And what else? Can we see any other thing? From the side view? No, this is the only face that's gonna be seen from the side view, right? Agree? So now let us draw the thing that we just see. So I have one point here in the side view. This point is the lower left corner of the side view. So what is the lower left corner of this side view or of this red face? It should be this point, right? So from this point of view, move to the right. You're standing here. Move to the right with 35. Move to the right with 35. Then I'm gonna jump up with 10. Move up with 10. Then I'm gonna move to the left. How long is this length, edge? What is the length of this edge? Go ahead. How much? 15? No, this edge, the 15, it belongs to this edge. I'm talking about this edge. Okay? Actually, it is a missing dimension here. We don't know. Because this should be 35, this edge is 35, right? We have to subtract the thickness, this thickness, which is already, yeah, it is already given by 10. I'm sorry, my bad. It is already given here. You see this 10? It means that this edge, it should be 10. So if you subtract 35 negative, then this is going to give us the 25. Make sense? So from this point, I'm going to move to the left with 25. Then I'm going to jump up this height. We said that before. This height it is 40. So it means that you're going to jump up. If you just measure 40 and your measurements and drawing is accurate, we shall end up with a line. The end of this line, it should be at the tip of the side view. We shouldn't exceed further beyond this line. If we exceed it further beyond this line, it means that there is something wrong. Then we're gonna move to the left with 10. This edge is 10. Then we're gonna close the shape. In addition to the L shape. So, for example, if I ask you, if I give you this like piece of wood, and I ask you to shape this piece of wood into this shape. So what you're gonna do, first of all, you're gonna cut an L shape of this piece of wood. Then you're gonna cut the inclined surface. Then you're gonna cut this opening. Then you're gonna cut the V shape. So in total, we do have 4 features within this object. We do have the L shape, we do have the inclined surface, we do have the opening, the square opening, and the V opening. So 4 features. In the side view, we presented only one of them. How about the other 3? They are there, but we cannot see them from this side view, but they should be represented by dashed lines. You got the point? All the 4 features, we can see them in the front view. This entire shape of the front view, it is the L shape. We can see the inclined surface. We can see the opening. We can see the V opening. But in the side view, we can see only one feature. The other 3, they are hidden to us. So they should be represented by dashed lines. Dash line, if you remember, this is the dash line. In this way. Make sense? And this horizontal line that we draw is going to assist us to locate these missing features. So for example, let us try to generate this rectangular opening. So assume that you're already standing inside it. Assume that you're already standing inside here. And you're going to try to look at it from the side view. You're going to see this face, right? Okay, this face will be seen like rectangular shape. So you have to represent this rectangular shape in its area, which it should be belong to this line. Do you see this line? Like you already assume that you're already standing inside the opening and you're gonna look at it from this side. So this edge should be seen. So if you try to project this edge, just project this edge, it will be projected into one line here and there is another line here. But this line, it should be seen like dash line. So if you try to draw a dash line over solid line, there should be dash line. dash line, and dash line. This is the projection of this opening from the side view. But it should be seen as a dash line. So if you try to draw a dash line over solid line, it will be seen solid. Dash line over solid line, it will be seen solid. So we're just gonna end up with just one dash line in this way. Make sense? So we got one feature. How about this V shape? Assume again that you're already standing inside it. Like you're already standing inside the shape here. And you're gonna look at it, so you're gonna see this edge, right? This face. So from its start point, you're gonna draw a line. From this its end point, you're gonna draw another line. This should be seen like dash rectangular shape. This is the face, this face. But if we try to draw dash line over solid line, it will be seen solid line. So dash over solid will be solid. Then we're gonna have dash line, then solid line. Then there is dash line over solid will be seen solid. So we're just gonna end up with 3 dash lines here, 1, 2, and 3. So we got the third feature. We still have one feature, which is this inclined surface. Again, assume that you're already standing inside it. Inside here. And you're gonna look at it from this direction. So you're gonna see this face. So again, assume that you're already standing inside the feature and you're gonna look at it from this direction. So you're gonna see this edge. This edge, if you try to project it from the start point into line, from the end point into line. So it means that this shape, it should be seen here, but the shape, it should be triangular shape. The shape of the surface, it is triangular shape. So if I ask you to draw it, you need one corner like this one, which it should be conceded to this edge, to this point, which it should be this point. So from this point, if you draw a line, the length of this line, it should be 15. Do you see this one? So I'm gonna draw a line with 15, but this line, it should be dash. So dash over solid will be solid. Then you're gonna end up with 1 point here. Then you're gonna drop down from the same point with 10. So I'm gonna draw a dash line with 10 over this solid line will be seen solid. Then we're gonna end up with another point. If we connect these 2 points, we're gonna end up with the inclined surface. Make sense? So we represented all the features over the side view. Okay, so now let us move to the top view. So again, we have to prepare for the top view. So assume that you're already looking to the shape from the top. So these are the line that you're gonna see. Only the horizontal lines and the inclined line that you're gonna see if you try to look to the shape from the top view, right? So I'm gonna see this line, I'm gonna see this inclined line, I'm gonna see this inclined line and this line as well. So this will be projected. Okay? In addition, you're gonna see this horizontal line in this way. Also, there is another line here that would be seen kind of if you're gonna look at it from the top. So all of this line should be projected. So from the start point, you're gonna draw a vertical line. From the end point of this edge of this line, you're gonna draw another vertical line. Then from this point, there is another vertical line. From this point, there is another vertical line. Make sense? Also, there is a line in the middle because this inclined surface from the start point, I draw a line. From the end point, I'm gonna draw another line in the middle here. If you see this line, this horizontal line, and from the start point I try to drop down, by chance we got that this point is identical to this one. And this point is considered to this line. And this horizontal line from start point, end point, so these are the line that we can project from the top view. Then you're gonna keep the same distance as you kept between the front and the side view. So I'm gonna keep this distance, the same one, and draw a horizontal line. So the top view should start from this line, the top view should start from this line going down, this direction. It means that all of this area should be the top view of this shape. But as you can see, we end up with two start points. This point is on the top right corner of the top view, and this point on the left top corner of the top view. You can start from either one. Now let us move to the 3D solid. For this 3D solid, we're still standing in the side view. You have to move back again to the front view. Moving to the front of view and try to put your hand on the top and give rotation to the shape. Put your hand on the top and give rotation to the shape. What faces that you're gonna see from the top view? What faces that you're gonna see from the top view? This one, you're gonna see this one and the inclined surface, and there is another inclined surface here in addition to this area. In addition to this inclined surface will be seen as well, right? So these are four things basically that there are four features that should be represented in the top view. So, but what will be the arrangement of these views? For example, we do have one option that we would have the top view in this way. So this is like option one, and we do have option two to have the top view in this way. Which one is correct? Okay, it means that this is, and there should be one line here. So this is the correct orientation of the top view, how it should be look like. Why? Because if you just try to give rotation to this shape and you look at it from the top, you're gonna see this one, this box, it should be on the right, this box, it should be on the left, these two inclined surfaces should be in the middle, this one it will be directly in front of you, then you're gonna see in the middle the inclined surface, right? So let us create this one here. So definitely we're gonna end up, this edge, it is 10 millimeter. So if you start from this point, it should be this point, agree? Then from this point, you're gonna drop down with 10 and close like rectangular shape in this way. Then this edge, it should be at a distance of 10, which it should be conceded to this one. This line on the top, this line here, it should be projected into a rectangular shape down there, right? So we're gonna have one rectangular shape, the same thing on the other side, you're gonna have one rectangular shape. In the middle, we do have this inclined surface from the start point and the end point. If you move down, we're gonna end up with this rectangular shape in the middle. So just gonna end up with one further line in the middle. Then this edge, we're gonna draw this shape. This shape, it will be seen like rectangular shape because we do have this edge, and there is another edge here. So it will be closed, not open. Okay? This edge, it is 25. So if you move down with 25 and close the shape with 40, then there is 25. This is gonna give us all of this face, but we have to form in the middle. We have to form here the inclined surface. The inclined surface, it should be with a length. This length, it should be 15. So from this point of view, measure 20 because this is 10 out of I'm sorry, it should be 15. 10 out of 40 gives 30, so this distance should be 15. So from this point, you're gonna measure 15. Then you're gonna go inside with 15 as well. Then you're gonna move with 10 to the left and 15. So this rectangular shape is gonna give us the inclined surface.